Oh, y'all, so 9.6 deals with solving exponential and logarithmic equations. All right, so the first half of this will solve exponential. Then that last half will solve logarithmic. So here's my steps to solving exponential equations. Now remember, exponential have this form, y equals a to the x. Okay, so first thing you want to do, if possible, rewrite each side using the same base. So if possible, rewrite each side using the same base. Because y'all, if we can get each side written with the same base, then we can use our base exponent property. Now, the base exponent property says if a to the x equals a to the y, so if the bases match, then that means the exponents have to be equal, so that x equals y. And we'll have a few problems, and I'll show you what we're talking about on that. So first thing you want to look for, can I rewrite them using the same base? If not, so if not possible to rewrite each side, using the same base, then we got to attack it in a different way. So if you can't rewrite it using the same base, the first thing you're going to do, you're going to take the log or ln of both sides. So here's what I do. I'll use the log unless it has the e in it. If it's got that e in it, then I usually do the ln, okay? Because remember, ln is a log base e. All right, so you take the log of both sides. The reason we take a log of both sides is so we can use the power rule. So using the power rule, bring the exponents down and write as a product. And that's what we were doing last week when we had exponents. Remember, we brought them down to the front of the log, and that was rewritten as a product. Now, once we've done that, we're ready to solve for the variable. So solve for the variable. And then, if needed, check answers. All right, so this will be our exponential. So let me start out doing some exponential. So these will just say solve for x. So I think they got about 8 or 9 doing the exponential. Then we'll switch it over and start doing the logarithmic, okay? So the first one I got 6 to the x equals 36. So this is going to help us solve for that x there. So, y'all, I'm going to bring up my chat. So my first question would be, since we got a base 6 on the left side raised to the x, can we rewrite 36 using the 6 for the base? And that would be yes on this one, okay? So what we're going to do, we're going to rewrite 36 as 6 squared. So since I can rewrite it using the 6, I'm going to do that. So that'll give me 6 to the x equals 6 squared. All right, so here we go. The bases match up. So since my bases match, I'm going to use this base exponent property that says if my bases match, then my exponents have to be equal. So that means x has to equal 2. No more work to do on that, so we're done. Now, if you wanted to check that, put that 2 in for that x, and that would give you 6 squared. Well, y'all, 6 squared does equal 36, so that one checks out. So that's my goal if I can get that to happen, okay? So let's look at this one. 4 to the 5x equals 16. So we got a base 4 over here with our exponent. So can we rewrite 16 as a base 4? And y'all write that as a base 4, that would be what? 4 squared. So 4 squared is 16. That 4 matches that base. So I'm going to rewrite these as 4 to the 5x equals 4 squared. So notice once again, my bases match. So since my bases match, that means my exponents are equal. So 5x has to equal 2. Now at this point, I solve for x. So it looks like I got to divide both sides by 5. So that'll give me my 1x equal to a 2/5. So if we put 2/5 in here, the 5s will cancel. That will leave me with 4 squared, and 4 squared does equal 16. All right, so notice these first two, I was able to rewrite my bases. So now they're going to give us a few where we can't rewrite the bases. So watch this. Number 3 has 5x equals 24. So there's no way I can rewrite 24 using the 5 as its base. Because 5 squared would be 25. 5 to the first is 5. So I cannot rewrite using 5 as a base. So y'all, that means since I cannot rewrite that 24 using the 5, my only other choice is I got to take logs of both sides. And remember, if you take the log of one side, you got to take the log of the other side of that equation. So everything for equations is still true. So when we take a log, we'll come down and do the log of 5 to the x equals the log of 24. So we've taken the log of both sides. Remember, my next step was to take that exponent and bring it down to the front and rewrite it as a product. So I get x times log 5 equals log of 24. All righty, so now the last step to get this X by itself would be to divide both sides by the log 5. So I'll come in and divide both sides by log of 5. So the log 5's cancel out on that side. Now, since we're dealing with logarithms in the calculator, it'll usually give you one parenthesis. You got to close the parenthesis on the 24 before you divide, and then open and close on the 5. So I'm going to actually do this one on the calculator to show you. So let me share that screen. All right, so I had log of 24, so I'm going to hit my log button, put in my 24, close the parentheses before you hit divide. Then once you hit divide, you'll hit log again, and then put in your 5, close parentheses. Now remember, we're rounding these 4 decimal places. So when I hit enter, let's see, I got 1.9746. Since that's a 3 after the 6, I'm going to leave that a 6. So that'll be 1.9746. So that's the main thing, y'all. Shut them parentheses when you're doing this on that calculator, okay? All right, next, number 4. We got 3 to the 9x minus 5 equals 81. So let me ask y'all, can you rewrite 81 using a base of a 3? You remember 9 times 9 is 81, and 9 is made out of 3 times 3. So we can definitely rewrite that. So we're going to rewrite 81 as 3 to the 4th power. So if you multiply, all good, you got it on the chat. So 3 to the 4th, good job. So that'll give you 3 to the 9x minus 5 equals 3 to the 4th. So since we was able to do that, my bases match. And since my bases match, that means my exponents are equal. So 9x minus 5 has to equal 4. All right, y'all, let's solve this. So solve for x. So I'm just going to add 5 and then divide by the 9. So we'll add 5. I get 9x equals 9. We'll divide by 9 now. And we get x equals 1. So if you check that, 9 times 1 is 9. 9 minus 5 is 4. 3 to the 4th equals 81. All right, y'all, here we go. 3 to the x equals 5. So listen, there's no way I can turn a 5 into a base 3. 3 to the 1st is 3. 3 squared would be 9. So there's no way I can rewrite that. So I cannot rewrite this 5. Using a base of 3. So since I cannot rewrite that, I'm going to take logs of both sides. So you automatically come in and take logs of both sides. So I'll have the log of 3 to the x equals the log of 5. All right, remember we did that so that we could bring our exponent down to the front. So that'll give me a x log 3 equals a log 5. Now remember, these logs, these are really numbers, okay? So that's how I can do everything I would with numbers with these logs. So remember what I did up here, I divided by the log. So I'm going to divide by log 3 on both sides. So once again on the calculator, put them in parentheses. So that'll cancel. So let me use my squiggly. So one of y'all want to round that out about 4 decimal places for us? 1.4650. Good, that's what I got. So good job. Not bad if you put these in right, okay? I'm trying to see what I want to do. All right, so number 6, I got a 10 to the negative x equals 8 to the 5x. So I'm not going to try to rewrite these using the same base because there's no way to do that. Since I got exponents on both sides that are variables, I'm going to start out by taking logs of both sides. So that'll give me the log of 10 to the negative x equals the log of 8 to the 5x. You know, we did that for one reason, so that we could bring our exponents down to the front. You'll get a negative x log 10 equals a 5x log 8. All righty. So since I got x's on both sides, I need to get all these x's on one side. So since this side was positive, what I did to this problem, I just came in and added an x log 10 to both sides. So this side gives you a 0. This side will give you a 5x log 8 plus an x log 10. All right, so y'all watch this. There's the x in 2 spots. The only way to solve for that x is to pull it out now like it was the greatest common factor. So we're going to factor out that x. In parentheses, we'll put everything else. So if we factor an x out of the first term, you get a 5 log 8. Plus, factoring the x out of the second term leaves you with a log 10. All right, so guess what? You got an x times all this in the parentheses. We're going to divide both sides by what's in the parentheses. So 0 divided by 5 log 8 plus log 10 will equal x times 5 log 8 plus log 10 divided by 5 log 8 plus log 10. These problems look a little long because you can't get rid of the logs till the last step. But y'all look here. That cancels, so that gives me my x. And y'all look at this. 0 divided by anything is going to be 0. So y'all's number 6 will probably end out with the same answer I got, okay? And if you put a 0 here, 10 to the 0 is 1. Put a 0 here, 8 to the 0 is 1. So it checks out when you put that 0 back up into that, okay? Just be careful on this one, because you do have that variable on both sides, okay? So to me, that's one of the trickier ones on here. All right, 7 has e to the t equals 153. So y'all, I'm not going to rewrite 153 using the e, so I cannot rewrite. Using a base of e. Now, since this one has an e, instead of taking a logarithm of both sides, I'm going to take a ln of both sides. Take ln of both sides. So that'll be the ln of e to the t equals the ln of 153. All right, so remember last week, ln of e to the x equals x. Okay, remember, ln is really a log base e. So when the base matches the base of the result raised to an exponent, the answer was always the exponent. See all this left side, ln of e to the t, that's just going to equal t in the long run. And then all we got to do is figure out what the ln of 153 is. So punching that on a calculator, let me go pull it up. So y'all, the ln is right by the 4. So punch in the ln. That was 153. Hit enter. And looks like what? 5.0304. Good job. I notice you're pretty good at rounding that thing off to 4 spots. So keep that up, okay? All right, same thing on 8. You got e to the negative 0.87 t is going to equal 0.89. So y'all, we're not going to attempt to rewrite this. There's no way to turn that 0.89 into an e base. So we're going to take the ln of both sides. So the ln of e to the negative 0.87 t will equal the ln of 0.89. So remember, I'm invoking this property again. So the left side is just going to equal the exponent, which was negative 0.87 t. That's going to equal the ln of 0.89. But notice, unlike this one, I now have to divide both sides by the negative 0.87 t. I meant by the negative 0.87. And that will equal to ln of 0.89 divided by a negative 0.87. So that'll cancel, leaving my t. All right, so remember on this one, put that ln, put that negative, put that 0.89 in parentheses before you divide by the negative 0.87. If you do that, let me see what you're getting on that one. So y'all, let me find where my screen share goes. All right, so on that one, I would punch in my ln 0.89, close parentheses, then divide that by negative 0.87. So once we do that and hit enter, let's see, we get 0.1339. That's a 4 after the 9, so that's going to stay a 9. So that's going to be a 0.1339. Y'all are not too bad. You just got to keep up with these logs until that final step. I don't figure out what the LN's equal until that last step, okay? Because if you round off too early, it'll mess up the final answers when you round them off. All right, so here's the last one using the exponential, and it's a doozy. This is a 6x equals 3 to the x plus 1. So y'all, sadly, we cannot rewrite this one. So since we can't rewrite it, we're going to take logs of both sides. All right, y'all, so that'll give you a log of 6 to the x equals log of 3 to the x plus 1. And y'all, we did that so that we could bring these exponents down so that we could solve them. So here you get an x times log 6. Now, since my exponent is an x plus 1, I'm going to put the x plus 1 in parentheses times the log 3. Because remember, it's not just a 1 times the log 3, it's the whole x plus 1. So put that thing in parentheses on this one. So this step, we really want to get rid of these parentheses. So we need to distribute our log 3 through the parentheses. So the left side will stay x log 6. That's going to equal x log 3 plus 1 times log 3 would just be a log 3. All right, so what's sad is we got x here and an x here. We need all this x's on one side, so I'm going to subtract x log 3 from both sides. All right, let me see. I got a chat here. Let me see. All right, so that was about homework. Yeah, homework lets you work it all the way to the last day. Okay, so you can always improve your scores on homework all the way up until that very last day. So the reason I didn't subtract the x log 6 from both sides was because I was trying to get all my x's on one side and then all my numbers on the other. So since I had that log 3 over here, that would have gave me all my logs on one side. And I still would have had to get the x's on one side versus the other. So watch what we're doing. We got an x log 6 minus x log 3 all equal to a log 3. Because see, this log 3 didn't have the variable with it. But now, since I got the x's on one side, I can factor them out like a GCF, right? So watch this. Both of these have an x in them. So if I factor out the x, in parentheses will be a log 6 minus, take that x out, leaves a log 3. All that equal to a log 3. So now, this one's ugly, but here's what you got to do. Since x is being multiplied by the parentheses, we need to divide both sides by those parentheses. So divide by the log 6 minus the log 3. And then over here, you'll do the log 3 divided by the log 6 minus log 3. So this side they cancel. All that's left is the x. So you have to be careful on this one. Put parentheses around the 3. But y'all on the bottom, since you got two parts, you got to put an extra set of parentheses around that denominator. So let me show you how I would punch that one in. So I would take my log 3 on the top, so log 3, close parentheses, divided by open parentheses on the bottom, do your log 6, close the small parentheses, minus the log 3, close the little parentheses, and then close the main parentheses on the bottom. So it's going to take an extra set of parentheses on that bottom. Now, when y'all hit enter on that, let's see. Ooh, round that one off, y'all. So that's going to be what, a 1.5. Let's see, we got an 849. The 9 has a 6 after it. So the 9 is going to round up, which means it's going to turn into a 0. But that means the 4 turns into a 5. So this will be a 5850. Okay, so since my 9 turned up into a 0, that means the 4 had to change to a 5, okay? So y'all, that's probably 2 or 3 tricky ones on this side with the exponential, okay? And just remember, close those parentheses on those logs. All right, so now we're going to get into solving logarithmic equations. So the first thing you got to do, look on both sides of the equals and combine any logs. So combine logs on each side if needed. So what we mean by combined logs is write as a single logarithm. And it's the stuff y'all did last week. If they were being added, we wrote them as a product. If they were being subtracted, we wrote them as a quotient. So after I do that, then I ask myself, do we have a log base equal to a log base? If we do, then we got what we call the logarithmic equality. And it's sort of similar to that base exponent when we looked at a while ago. Logarithmic equality says if I got a log base A of m equal to a log base A of n, if the logs match up with the same base, then that means m has to equal n. All right, so if you don't have that situation, then rewrite it as exponential. Remember, we learned that last time. The base of the log is the base of the exponential. M was the result, and then it equaled the exponent, okay? So once we rewrite as exponential, we then solve for the variable. And then finally, check if needed. Now remember one thing. When you check these answers for the logs, remember, cannot take logs of negative numbers. Remember, if we try to take a log of a negative number, the calculator gives us an error because it does not exist. So check your answers if they're negative. You cannot keep them negative answers, okay? All right, so these will start out mellow and then they'll sort of add more as we go. And y'all, these will say solve for X. So these start at number 10. Number 10 says log base 4 of X equals 2. So the thing I'm noticing on this one, I don't have any logs to combine. I've already got a single log here. I don't have logs on both sides to do the log base. So that means we're going to step to 3, which says rewrite as exponential. So we're going to rewrite as exponential. So the base is 4. Exponent is 2. And that's going to equal that result of an X. All right, so only one more step is to figure out what 4 squared equals. And let's see, 4 times 4 is what, 16? Equal to my X. So if you should check that on the calculator, log base 4, put in a 16 for the X, you would get an answer of 2. So that's the trick on logarithmic, is turning them into exponential if you need to. All right, let's see what I got here. Log looks like base 10 of X equals -5. Same thing here, you're going to rewrite as exponential. So that is base of 10, exponent's -5, and that's going to equal X. And you know, if you punch 10 to the -5 on your calculator, it should give you a 0.00001 equal to your X. All right, y'all, number 12. I'll probably have to bring this down a little. All right, so number 12 has a log base 6 of 4x minus 4 equals 4. So you got a single log already. So we're going to rewrite this one as exponential. Oh, Davis, I just noticed you had that up there. So I must be getting a little lag with getting your messages in. So good job. 0.0001. All right, y'all got a base 6. Exponent 4. That's going to equal 4x minus 4. All right, one of y'all figure out what 6 to the 4th power is, because that's going to be a big number, I'm afraid. So 1296, yep. So 1296 equals 4x minus 4. So y'all, at that point, we're just going to solve for the x. So let's see, add 4 and then divide by the other 4. So let's add 4. So 1300 equals 4x. Divide both sides by 4. So what are y'all getting on that? 1300 divided by 4. We got 325, looks good. All right, so notice these first three had single logs on one side, so you had to rewrite all these as exponential. So y'all now, they're going to sort of change it up a little bit, okay? So here we go, 13. Let me pull this back up. So 13, I got a log of x plus a log x minus 21. That's going to equal 2. So remember my first step said combine logs on each side. Well, I got 2 logs on the left side, so we need to combine logs. Since they're added, remember when logs were added, you rewrote them as a product. So this would be the log of x times x minus 21. That's going to equal 2. Now, I think also what I would do to this before I solved it, I would distribute that x and write this as a product after I distribute it, okay? So bring down that log. X times x is x squared. X times negative 21 is a negative 21x. And that needs to be in parentheses, all equal to R2. So I go one more step before I rewrite it. I'd like to get that multiplied out, okay? So at this point now, I got a single log equal to a number. Now we can rewrite as exponential. Uh-oh, y'all. They didn't give me a base by this log, so what would the base be? So definitely a 10, good job. So we got a base of 10, exponent of 2, that's going to equal to x squared minus 21x. All right, so let's figure this out. 10 squared, we know that's what, 10 times 10. So that'll be 100 equal to our x squared minus 21x. So here's the thing on solving this one. Since you got an x squared term, we need everything on one side equal to 0. So that means we need to subtract 100 from both sides. Because we need a 0 over here. That's going to equal x squared minus 21x minus 100. At this point, you can use the quad to solve this. A is 1, B is negative 21, C would be negative 100. But y'all, I'm going to solve it by factoring. I got an x and an x. Last number is negative, so I got a positive and a negative no matter what. I need factors of 100. That'll subtract and give me 21. So 25 and 4, 25 will be negative like the middle number. So negative 25 and 4 equal negative 21. So now take both of these factors and set them equal to 0. That way we can actually get our final answers. So this would be minus 4. So I get x equals a negative 4. This one I would add 25 and get x equals 25. Oh, so Davis, you got x equals 25, which is correct. So why did you not take this answer? Because it's negative. Good job. Because if you put that negative 4 in for that x and try to do a log of a negative 4, it's going to give y'all an error message, y'all. So you cannot take negative answers. The only answer that we can take is that positive 25. All right, y'all probably have to turn over to get this next one. So 14, they start giving us everything. Watch this. Log base 3 of t plus 16 minus log 3 of t plus 7 is going to equal a log base 3 of a t. So remember, the first thing we want to do is combine logs. These are being subtracted, so when we rewrite it, it's going to look like division. The positive factors on top and the one that's being subtracted will be on the bottom. So bring out your log base 3. The top is a t plus 16 over that bottom, which is a t plus 7. That's going to equal a log base 3 of a t. Now, do you notice what happens? This log base 3 matches that log base 3. So the log bases match. So since the log bases match, this result, t plus 16 over t plus 7, is going to equal this result of a t. So t plus 16 over t plus 7 is going to equal t. And y'all, I'll tell you a trick on this one. Remember, I got t's everywhere. So on this one, I'd probably put a 1 under the t and I would cross multiply this. So I'm going to cross multiply. So this top multiplies by that bottom. So 1 times t plus 16 is going to be a t plus 16. That's going to equal this bottom times this top. So remember, t plus 7 both have to multiply by the t. So the t times the t gives me a t squared plus 7 times t is a 7t. All righty. Now, since we got this t squared, we need a 0 on this side. So to get a 0 over here, we'll subtract the t from both sides. And we'll subtract 16 from both sides. So y'all notice this side is now 0. This side will have a t squared. 7t minus 1t leaves you 6t. And then at the end is your negative 16. All right, if you're doing quad, you'd have 1, 6, negative 16, okay? So let's see, you got a t and a t. And you'll notice most of these are going to be negative at the end, which means you're going to have unlike signs in this. So y'all, what factors is 16 will give me a 2. So 8 negative 2. So let's go 8 negative 2. All right, so the rest of this is just solving for the t. So you're going to subtract 8 on the first one and get t equals a negative 8. Add 2 to the second one and get t equals a positive 2. So my final answer will be what? T equals 2. Good job. Cannot take that negative 8 because if you punch that in, that'll give me a error message. So the only answer would be t equals a positive 2. So I'll tell you what, they not too bad, but boy, they go back on everything you know about solving equations on these, okay? 15 log base 4 of x plus 1 minus log base 4 of x equals 3. So see what we got? We got to combine logs again. They're being subtracted. So once again, it'll look like division. So bring out your log base 4. The positive factor goes to the top, x plus 1. The factor being subtracted goes to the bottom. And all that's going to equal a 3. So look here, we got a log equal to a number. So at this point, we got to rewrite this one as exponential. So my base is 4. Exponent is a 3. And 4 to the third is going to equal x plus 1 over x. So let's figure out what is 4 to the third power. Remember, 4 times 4 times 4, good job, 64. So 64 will equal x plus 1 over x. And y'all, I'm probably going to put me a 1 under that 64 and cross multiply again. I like to cross multiply when I got single fractions here, okay? And remember that anything with a number can be made into a fraction by putting a 1 under it. So this top 64 multiplies by the x. So that'll be 64x. The 1 multiplies by the x plus 1. And that'll give me x plus 1. All right, so I need all the x's on one side. So I'm just going to subtract this x from both sides. That'll give me 63x equals a positive 1. And y'all, the last step, divide both sides by 63. So notice those 63's cancel. X equals, can't do nothing to that. So that'll stay 1 over 63. So y'all, the big trick on this is getting it down to these single logs so that we can rewrite them as exponential. Now, if we got logs on both sides, we get it down to a single log equal to a single log so that we can make them have the result equal the result. Oh, look at this one. It's got all kinds of stuff. Log base 3 of x plus log base 3 of x minus 1 equals log base 3 of a 6. So this left side, the first thing we got to do is write this as a single log. So we need to combine logs. Now check this out. These are being added. So since they're being added, we write them as multiplication. So we bring out our log base 3. We'll have x times x minus 1. All that's going to equal log base 3 of a 6. So like I did a while ago, I would probably multiply that real quick so that I get a log base 3. X times x is x squared. X times negative 1 is a negative x, all equal to log 3 of a 6. So we're happy on this one because my log bases match. So since my log bases match, this result equals that result. So x squared minus x equals 6. All right, so x squared again. So what we need is a 0 over here. So subtract 6 from both sides. So x squared minus x minus 6 equals 0. So y'all, once again, I'm going to factor that. I got an x and an x. That's negative. So one's positive, one's negative. And you'll notice on these log equations, you're probably going to have unlike signs on these for probably 95% or more of these. But I need, oh, you got me. All right. So you got me a +2 and a -3, because that'll give me a -1. So I'm just going to set these equal to 0 now and solve. So I'm going to get a -2 and a +3. So Davis, I think you really like doing some factoring. All right, y'all. So final answer will be what? X = 3. Good job. Cannot keep that negative answer. All right, y'all. So we got one more on this one. Number 17 is the last one. So let's see what we got. Log base 3 of x plus 12 plus a log base 3 of x minus 12. All that's going to equal a +4. All right, so let's combine logs. They're being added, so we're going to write this as a product. So we'll have our log base 3, x plus 12 times x minus 12, all equal to 4. And I'm going to do one more step before I rewrite this. I'm going to figure out what x plus 12 times x minus 12 is. So I'll do that on the side. Hey, these are conjugate pairs. So remember, conjugate pairs, I can shortcut. X times x is x squared. 12 times -12 is a -144. So remember, when you got conjugate pairs, you don't have to FOIL out that whole thing, okay? All you got to do is the x's times each other, then the numbers times each other. So y'all, this will give me a log 3 of x squared minus 144, all equal to a 4. At this point, I now have a single log. I'm going to rewrite as exponential. So remember, if I don't have logs on both sides, I have to rewrite as exponential, okay? All right, so let's see. We got a base of 3. Exponent is 4, and that's got to equal the result, x squared minus 144. So y'all figure out that with 3 to the 4th power. So that's going to give me 81 equal to the x squared minus 144. So y'all, once again, I got an x squared here. So I'm going to get everything on one side equal to 0. So I'm going to subtract 81. I'm going to get 0 equals x squared minus, what's that? 144, 81. That's going to be 225, it looks like. That's a -225. So one's positive, one's negative. So how about this? What factors of 225 will give me a 0 if I subtract? And y'all, this is perfect squares. So basically, you just got to take the square root of 225 to give me these two numbers. So what do y'all got, a 15? Good job. So set both these equal to 0. First one, I'll subtract 15. Second one, I'll add 15. And guess what? Cannot take the log of a negative number. So the -15 is gone. The only answer will be x equals a +15. So y'all, it's real important when you get these two answers, you throw away those negative answers on these logs, okay? All right, y'all. So any questions? So be careful when you're doing the first part of this with the exponential equations. When you push those LNs and logs in there, you got to close those parentheses on those numbers before you do any dividing, okay? On the log part of it, check those answers because we cannot keep negative answers for logs, okay? All right, y'all, let me see. I'm looking on my chat. So any questions? All right, so let me stop our recording.